Welcome everyone to Hawk Happenings, a look into the Cornell Hawk's nest. And today I'm going to be one of your hosts, Rachel Meady. I am the project leader for BirdCam's lab. And with that, I'll turn it over to Charles to introduce himself.
Hello, everybody. I recognized a bunch of names actually that came through the chat, so it's really fun to try to be both looking at the camera, thinking about what we're going to talk about today, and smiling as I see several names and locations that I recognize from the time I've spent working on the project. So just a quick, some of you know me, but I've been studying birds and animal behavior since I was in undergrad at Allegheny College, then I moved on to the University of Montana to study black-capped chickadee wintering behavior, where I got my master's, and started working at the Cornell lab back in 2006, managing the visitor center in Sapsucker Woods before basically transitioning to the BirdCam's project in 2012 to start it. And while I'm not currently involved in studying red-tailed hawks, I did have an awesome opportunity early on in my career to study, to take part in a study, basically to work on a study where we were tagging red-tailed hawks and other hawks on migration. So this is a picture of a much younger, hairier version of me about 23 years ago. Holy moly. And that is a beautiful dark morph red-tailed hawk that I had trapped that day. And you can see the band that we put on its leg there. So I've always had a fascination with red-tailed hawks. Actually, one of my first nests that I ever found as like a teenager was a red-tailed hawk nest down in the park. And it's always been something that resonates with me. So I just wanted to say thanks for y'all to showing up, and I'm really looking forward to talking with you about the hawks.
And how's it going, everybody? My name is Ben Walters. I'm the BirdCam's communications specialist. I've been working at the lab now with the BirdCam's program for 4 years, since 2016. I came by way of the University of Nebraska, and then myself and folks in Canada, I went to Western University in London, Ontario for my master's, studying predator-prey dynamics with birds there. And now I live a stone's throw away from the Cornell lab, loving life, working with the BirdCams. So my main task today will be sort of handling the Q&A session, throwing back some questions to Charles and Rachel, and sort of moderating some of the answers in the chat and Q&A bar as well. So happy to be here and look forward to a fun hour with you.
All right, so to dive right into things, I'm going to reshare my screen again. And you all got to learn a little bit more about us, and we want to know more about you and your experience with us and the CAM. So I'm going to launch a poll, which is something we're hoping to use throughout the webinar today to interact with you all. And you should see that come up on your screen. And we want to know, how often do you watch the red-tailed hawk cam during the breeding season? Right now, they're not there as much, but back in the throes of spring and summer, curious to see what you all are up to. All right, I'm going to go ahead and stop it for now and share it back out. It looks like we have everyone across the spectrum, from you've never watched the cam before to you are a multiple time a day viewer. So thank you everyone for letting us know how familiar you are with the cam, and we're excited that you're here today to learn even more. All right. So to orient where we're going today, I want to kind of map out what we're going to be talking about. First, I want to give an overview of what BirdCam's lab is and what Hawk Happenings is within that. And then I want to turn it over to Charles to talk a little bit more and lead us through some clips about the behaviors of hawks and the weather we see at the nest that inspired the community to ask the questions that we did. And then we're going to touch on how we collected the data and the new insights that the data have given us into hawk behavior at the nest. And then we're really excited for, and maybe my favorite part of today is going to be the discussion, where it's a really a two-way street where we're here to share what we have with you all, but we want you to participate and help us kind of co-create this exploration of what we can know about the hawks at the nest through this process. So with that, BirdCam's lab. So many of you are familiar with BirdCam's lab, but for those of you less familiar, BirdCam's lab was inspired by cam viewers who were watching the bird cams, collecting data to answer their own questions. And we saw that at the lab and wanted to create an online space, which we've now created, BirdCam's lab, where viewers can work with scientists to steer those investigations and to get from not only observing the cam, but asking questions, collecting data, analyzing that data and sharing it back out. So this provides a space for viewers and scientists to come together and allows people to jump in and out of the scientific process any which way along the process. To date, we've done 3 investigations. We've done Battling Birds, Panama Live, and Hawk Talk, which was the first investigation with the red-tailed hawk cam. And Hawk Happenings is the second investigation with the red-tailed hawk cam. Hawk Happenings is an investigation where we were watching the cam and thinking about what we wanted to understand about this nest that's located above Cornell's athletic fields. And after watching the cam and having discussions back and forth among the community and scientists, we realized we wanted to answer these 2 research questions. The first, getting a better understanding of what the frequency of certain hawk behaviors are. And second, does this frequency vary with weather? And I want to continue to understand what your experience with us has been so far. And so I'm going to launch a second poll. And I'm curious of those of you with us today, did you help come up with or design the research questions? You guys are very quick in voting. Thank you, thank you. And you can answer from yes to no to I don't know, or I wish I could have.
This is all also a very good exercise to remember in the next couple of weeks if you haven't voted. If you're in the United States anyway, please make sure you get your vote in. Just a little plug since you're voting right now, it's almost this easy.
Very true. Completely agree. All right, I'm going to go ahead and end that poll for now and share back out the results. It looks like we had about 21% of you did help come up with this research question and design it. Majority of you did not. And then some of you wish that you could have, and some of you couldn't quite remember. It has been a while. We started this investigation back in April, so it's been a long year. But what I want to point out is I'm thrilled to have many of you here today that didn't help us come up with the question because, like I said, we designed it so that you can jump in and out of the scientific process any part of the way. All right. So with that, I will stop sharing the results and I will stop sharing my screen. I'm going to turn it over to Charles, and Ben's going to also share the video to highlight some of the clips from this past season that inspired the community to come up with this question in the first place, to make sure we're all on the same page.
I also think it's important to note, you can go ahead and start things going, but these are clips primarily from the last season, but we could pick lots of examples from across all the seasons. And this clip, this came from this spring. I was watching this live where these squalls were ripping through Ithaca, in May. And a time when we don't normally see weather, well, we don't normally see weather like this. But for the first time in my memory, since 2012, Big Red was literally blown off the nest. You can tell from her just the way she moved out of the nest. That was an unexpected thing. There was no grace to that. Typically, when you don't see grace in an animal, it means they weren't expecting that. And for for those of you who didn't see this live, you might be worried about that nestling behind her that is still outside the nest. But eventually that chick did climb right back in and entered sort of via the rear passageway underneath Big Red's legs. This is another, challenging reality of living in Ithaca. And we get a lot of rain. I mean, everywhere there's a lot of rain. In this case, there had been a horrendous downpour where people were seriously worried about Big Red because she sat on the eggs overnight and was just drenched to the bone, unmoving. And you can see, like, oh my gosh, you can almost see the skin underneath those feathers. It looks like, she's actually gone for a swim there. And yet the birds are so much more resilient, I think, than we give them credit for. I also think it's cool to see a clip like this where you can look and see her feathers and actually understand a little bit more about the anatomy of a bird, in that you can see where parts of it end that you can't see when she's all fluffed up. And you can realize those feathers actually grow in tracts along their body. They don't actually grow uniformly across their body. So when they get wet, sometimes you see, oh yeah, there's a little central patch in the middle of her back that all of those feathers are coming out of, and then they sort of blanket out across the areas that don't have those feather tracts. So it's kind of cool to see. But if you can imagine how hard it is for an adult hawk to be dealing with that, these chicks that are just downy and lack any sort of waterproofing, that just shows the dedication as well of Big Red. And I'm sure that many of you, if you've been watching this cam for more than a few years, this would probably come up in the chat, so I'll say it right now. There was an incredible highlight from several years back when Ezra basically leaned over Big Red and some very young nestlings in a very cold sort of early spring or late spring rainstorm, and stood there for like a half hour sheltering her and the chicks from the rain. So this is something we see over and over again. And one of the things I like the most about weather, before we get to this next clip, and you can feel free to chime in the chat what you like about weather and watching these birds, but like it's something I can actually relate to. When I see that soaked, sodden bird, I can relate to being caught out on a walk and being just soaked to the bone and the discomfort that I feel. And yet I can go inside. So it's a good touchstone for thinking about the experience of these animals and the experiences that we can, because I don't know what it feels like to fly, for example, but I know what it feels like to be wet. You can go ahead, Ben.
Yeah, I'm going to go ahead and start sharing some of the different behaviors that we were looking at during this Hawk Happenings project, or the investigation. So I'm just going to serve up the clips, and we'll kind of give you a preview of all the different things we were looking for while participants were collecting data.
Right, and you can keep those weather clips in mind. That one of the things the questions was wondering, as we look at these behaviors, how might those weathers change these behaviors, like Big Red coming in here to brood the young. And if you're unfamiliar with the terminology, just remember brooding is basically when you can think of it as like the equivalent of what she does to eggs when she's incubating. She's brooding these chicks because they can't thermoregulate yet. And certainly because they're just covered with down, they don't have the ability to stay dry. And that's an important thing. Some people refer to her as the mombrella, or more broadly, this phenomenon as mombrella. That little shimmy shake. I know in the chat there's been lots of different names for this behavior, so feel free to chime in, those of you who are longtime viewers, because there's certainly a bunch of fun, almost slang that comes up around these bird behaviors. Gosh, it looks so comfortable there, even with that kind of half disheveled piece of prey. Now, vocalizations are actually not that common in the nest. And here we're seeing both a vocalization and a prey delivery by Arthur. So Big Red's sitting on the nest. She's vocalizing to him, encouraging, probably saying, great job, good job, psyched. Could be saying lots of things, but they're communicating because they're in the same place at the same time. He brought in a piece of food, flies off. This was another behavior. Both of those behaviors were things that we were tracking, and they're happening sometimes at the same time. That's one of the things that makes studying behavior so complex, is because lots of things happen at the same time. So right now we're talking about, in this case, the behavior would be feeding, but you know, she's trying to feed the young. Those young are also doing things as well, right? So depending on what we're studying, and in this case it is feeding, we want to know how often they're being fed. You can be taking lots of data, and that's what makes it so challenging to study behavior, and why it's great to have a large number of people potentially participating in that. Ah, there it is, the red-tailed Roomba. That's actually the one that I was thinking of. Thanks, Raylene. I knew somebody out there would jog my memory. And thanks for the clarification, Jackie, on Mombrella. Technically is when she has her wings spread a little bit more. I kind of think of her more broadly as a Mombrella overhang awning. But you can see in this clip, we could be talking about her feeding one chick, multiple chicks. All right, it's a complicated question. And here we have Arthur coming in with a piece of prey, handing off to the young. And now these young are now old enough. You can tell they're much bigger. You can see some of their plumage coming out, their adult plumage, or their second molt, basically. And they're actually trying to defend that, kind of take ownership over that prey item, which is something we don't see them do when they're younger, because they really just aren't that coordinated, and the prey is often bigger than they are. So that's called mantling. And then finally, you can see we're going through sort of a developmental phase here. We get to watch them start preparing to leave the nest. And in this case, the behavior that we started recording is flapping. So we're going to watch these guys, especially that one in the middle, I think, do some flapping in this highlight. And what's interesting is we had only a small number of buttons that you could be mashing at any time. And so as the season moved on, we would swap out behaviors that were really no longer behaviorally relevant and add in things like flapping. So when they're small and they don't have any flight feathers, they're not flat. Yes, and as Janet mentions, flapper-sizing is also another fun. There's got to be a word for these kinds of words, but it's another fun word from the community. Great comment in the chat here. The hawks call a lot when they're flying around, and I wonder why. It's a great question. So that's one of the things they're doing, is potentially communicating with each other, but also to other hawks around them in adjacent territories, saying, hey, just remember I'm here, you know. And so vocalizations are both a function of communicating between potentially two individuals, within a pair. But then that pair is also maintaining a territory, and those vocalizations can play an important role in broadcasting who owns that territory to those around. Portmanteau, yeah, that's kind of we're combining words. In this case, we're truncating some of them, but yes, thanks, Charlotte. That is actually the word I was thinking of. And I'm not sure it's quite accurate, but that is exactly the word I was thinking of.
That was awesome. I always love watching those clips of the hawks and thinking back. That's, for many of you tuning in, watching the cams is kind of that like way scientists really fall in love with science, is that observation. And so it's so fun to spend some time rewatching the hawks and remembering why we asked the questions we asked. And so I do want to bring us back to those research questions we asked. And I want to have just kind of a back and forth with you all, thinking through, based on what we know and based on kind of what we just watched in the clips, thinking about what we would expect the answers to our questions would be. And so I'm going to go ahead and share my screen again. And I want to put a poll back out to you all. And I want us all to think about, how does the frequency of hawk behavior change as the breeding season progresses? So we were interested in this frequency question, but I want to specifically pose it in terms of thinking about as the breeding season progresses. So I'm going to put this poll out to you all and invite you to answer it for vocalizing, prey deliveries, feedings, and the different nestling activities that we saw. So the mantling of the prey, the flapping, the walking, that all kind of falls into that category. And you have the option to say, oh, it's going to probably stay about the same. Maybe it increases, maybe it decreases, and you can think about what you've seen on the cam and what you know about birds in general to help inform why you might say one thing or the other.
Yeah, and this is, you know, I think part of the reason why Rachel wanted to ask a question like this, have a poll like this, is because this is kind of this is the first step in kind of designing something to tell whether or not you're right. You kind of got to take a stab at, either you're stabbing completely in the dark, you're saying, well, I've seen a lot of this, so I think vocalizing is going to go down over time. Yeah, it's a great question. Robert just asked, vocalizing by adults, chicks, or both? Well, that's a really important probably question, right? So let's just say combined, at least for now. And if you've already put in your answer, it's okay. This is just really to kind of take the temperature and to walk you through the same way that we walk through, and probably many of you already walk through kind of hypothesizing about what's going on around you in the world.
Yeah, we did some of this in the beginning of this investigation. I wanted to kind of bring this part back because this is really, I wanted to contextualize why we're thinking the things we're thinking. And thank you to everyone that's voted in. I'm going to go ahead and end the poll for now. It's okay if you didn't get your answer in. I'm going to share the results back out to you all. Looks like most of you would expect that the frequency of vocalizing will increase as the breeding season progresses. And if you have a reason why you said any of your answers, you can go ahead and put them in the chat, because I'm going to talk a little bit about that in a couple minutes. And then prey deliveries, also would expect them to increase. Feedings, would also expect them to increase, the majority of you would say. And nestling activities, looks like the majority of people are thinking they would increase, but there are some of you out there, and I think probably have very good reasons and expectations why you might expect it to stay the same, or that you might expect it to actually do the opposite, which is decrease. And what's part of this whole process and thinking about our own experiences, what we're watching and seeing what we think will happen when we collect data, is contextualizing it with the literature and what other people have studied. And so I want to share just a little bit of what scientists have studied and what they've found in terms of the frequency as it progresses over the season of these behaviors. So what scientists have found is there really isn't that much known about the frequency of vocalizing overall at a hawk nest. There is some sense that it might increase as the chicks get older, but it hasn't been studied very rigorously. For prey deliveries, for red-tailed hawks, the literature says there's no change in terms of prey deliveries. We know from some data collected by people that watch the red-tailed hawk cam that might not be the case. It might actually be increasing. And then with feedings and nestling activities in other raptors, researchers have found that the feedings increase in frequency and that different nestling activities are thought to increase as well as they develop and are able to do the different activities.
I think you're all bringing up in the chat here the idea that, wait a second, I can think of all sorts of exceptions to these broad categories, and you're right. And so this comes down to how you actually start to design your study specifically to answer specific questions. And so that's why, while it might seem a little vague, the fact that you're thinking about, like, wait a second, wouldn't the feeding frequency change as the nestlings begin to feed themselves? Maybe we were measuring both of those things, right? Or maybe you're measuring it and you're just looking at the number of times that they're eating during the day. So feeding, whether it's self-feeding or being fed. And so I think that it's an important thing to point out that this is exactly, again, come up with an idea. I think this probably increases. And then you start thinking through it and like, well, which part of it am I talking about now? And like you start to think of all the things. And this is part of the scientific process. Also, it looks like some of you are like, wait a second, I was thinking of something different. And this is where the communication, both, if you're a scientist talking to somebody, if you're part of a group of people trying to study something, actually understanding like the words that you're choosing to describe what you're studying, everyone needs to be on the same page to actually get to the answer to that question. Yeah, short questions can be vague and ambiguous.
Yeah.
Long questions don't sometimes get read by people. So it's sort of it can be depending on the venue, a challenge, but that's all part of the process.
Yeah, definitely. And in interest of time, we're thinking about frequency, and we posed the first research question. We kind of narrowed in to understand what you all would think in terms of breeding season. We could also think about this in terms of within a daily variation. So thinking about within the hour of a day, how these different behaviors vary. But I'll skip that poll for now and just let you all know the literature doesn't really know For the behaviors that we were studying for vocalizing, feedings, and nestling activities, there's not a good sense of how this varies throughout the day. The best studied behavior is prey delivery. And we know from some peregrine falcon studies that there's this idea that it fluctuates with a peak in the morning and a peak in the evening because of this idea that it mirrors prey availability, which is pretty interesting. And so in terms of the hawks, we can see later on in the webinar today if our data match this and if we can fill in the gaps here for these question marks that we don't know. Our research question didn't just involve frequency, it also involved temperature. And I'll give us all a chance to weigh in for the temperature poll because I am curious what you have to say with that. So we thought about frequency as the breeding season progresses. There's this idea of thinking about frequency within a day, but what about frequency and how it relates to temperature? And temperature is one way to measure weather. As someone posted in our data exploration pages, it's not the only way. So we can think about weather in different ways, but if you had to think about how behaviors might change with temperature, as temperature increases, would you expect the hawks to vocalize more, vocalize less, stay about the same? And how would you think about prey deliveries, feedings, nestling activities as temperature increases?
And Robert, we see your question there about within the day or across a season, and I would say both.
Agreed. I would say both. This question isn't specific to either, but that would be really important to know what you are interested in.
And while you guys are sharing your thoughts, I've been reading through the chat here, and it's great that people are sort of digging into the idea that even something like prey delivery winds up being a pretty complicated equation, and even understanding who's delivering the prey. So Big Red might have arrived to the nest with prey, but it may have been given to her by Arthur, right? So, and the size of the prey is going to dictate potentially how much prey is delivered, the hunger level of the chicks, the hunting skill of the adults. All of those things definitely figure in. So it might take, you know, let's say 17 chipmunks to add up to one decent sized rabbit, right? How long can that sit around in the nest for them to forage off of? You know, that's another question. So maybe you don't need to bring more prey because it's spread out over a longer period of time.
All right. And in the interest of time, I'm so thrilled to see so many of you chiming in for what you would think or expect for these different things. I'm going to end the poll for now, so no worries if you didn't get a chance to tune in. But just to share back out with you, let's see where everyone's thinking in terms of temperature. For vocalizing, many of you think it will stay the same. Some think it increase or decrease. Prey deliveries and feedings, it looks like it's kind of spread across. You guys aren't quite sure if it would stay the same, increase or decrease. And there are probably great reasons that you all are thinking about that's driving why you might think that would be. And then for nestling activities, it looks like the majority are thinking it would increase, but then there are some people that are like, hey, it might actually stay the same or even decrease. And this could also relate to the fact that you can measure temperature very differently. Are we thinking average temperature, minimum temperature, maximum? For now, we're going to be thinking about the temperature measured at each hour. And that's the temperature I'm referring to, but that's something we can also continue to think about. And just to kind of continue to walk through this process of our observations and how it meshes with what's already known, I want to just touch on what scientists have found in their own studies. And when they've looked at raptors and have considered these different behaviors at the nest, they haven't looked into vocalizing, but they have looked into prey deliveries, feedings, and nestling behaviors, and have found that as temperature increases, that they see an increase in these different things. And there could be a variety of reasons for why that is. One is the fact that if temperature increases, the hawks don't have to worry about their own thermoregulatory maintenance. So they don't have to worry about maintaining their own temperature as much, and they don't have to conserve energy, so they can go do other things. Same with the nestling behaviors. If they don't have to worry about keeping warm, they can flap and they can walk around. That's just one idea. And great point from some people in the chat. The questions are vague, and that's part of the process of science too. So we started out with these kind of broad questions, and we're trying to narrow in, and that's what we're trying to walk us all through today to get us on the same page.
Yeah, so when you think about these questions that are being posed in these polls, the idea was to kind of promote a little bit of discussion and thought about, you know, different ways you might think about these questions. And as we go through this webinar, we're going to focus in on a couple of more specific examples towards the end that are going to relate to the data that were gathered by people in the community.
Yeah, so speaking of that, so hawk happenings, we collected, yeah, go ahead, Charles.
I was going to say, we did have one question just for you to hit again,
Yeah.
what we're considering nestling behaviors, just that everybody's on the same page, because it's a composite for these little polls, but it's something that is teased out
Definitely
in the data.
Yeah, so nestling behaviors, this is a screenshot of the tool we took. If you look at the second button up from the bottom in this tool, the nestling activity, it was food defense, it was flapping, and it was walking. So those are the three behaviors through talking with everyone in the community we thought would be the most relevant to our question and thinking about how that varies with weather. So those are the behaviors we're thinking about, because there are a lot of nestling behaviors we could study, but we had limited space for buttons, and so those are the ones we thought were most relevant. And so what you're seeing right now is a screenshot of the data tool we use. And so we were able to watch the red-tailed hawk cam live and collect data as we were watching it happen. And so we watched when prey was delivered, the chicks were feeding, and the different nestling activities and vocalizing. And I'm curious of everyone tuning in today, how many of you were actually part of that process? Because I want to get a sense, another temperature of the room per se. And I want to know, did you actually help us do this? Did you participate in collecting this data for hawk happenings? And you can answer yes, no, I don't know, or that you wish you could have. Okay, you guys are so quick with your fingers.
I will mention, since we're waiting for the votes to come in here, there was a question that came in the chat quite a bit ago, asking why don't the hawks nest in a more hospitable location or climate? And the fact of the matter is, these hawks are just incredibly tough. This is not really an inhospitable climate here in Ithaca anyway. And while the nest site on a light pole above the athletic fields on Cornell's campus might seem like, it's kind of like a weird spot, it's actually a really, as it's proven, I mean, like over the last 8 years, as far as like getting chicks from egg to fledging out of the nest, every single year they've had a nest on one of these light towers, they've raised all 3 chicks and gotten them to fledge. The success of those fledglings, once they've left, it's been more challenging, but that's also pretty common across raptors in general and red-tailed hawks in specific. You know, where they're nesting, they're surrounded by a lot of great habitat with a lot of prey. There's not really much in the way of predators. So more natural environments where they might find like a big old tree and a hedgerow along a field that might be good hunting territory. It might also be a great spot to be a great horned owl. And there'd be competition and potentially predation. Great horned owls eat red-tailed hawks, or they certainly kill them whenever they encounter them. So, you know, it might not seem like this ideal spot to us in some sort of idealized way, but it actually, you know, might be the ideal spot if you're a red-tailed hawk in this part of New York.
That was a great question. And just to reiterate, if anyone has questions, just so we don't miss them, because we might not get to all your questions in the chat, put them in the Q&A and we'll make sure to hit them in the discussion today. And I'm going to go ahead and end the polling. It looks like we have about half and half saying yes or no to collecting the data. And a lot of you saying you wish you could have, I wish you could have too, but we will have hopefully more opportunities in the future for you to collect data with us. But because many of you didn't help collect data, I want to take a moment and get us all on the same page and turn it over to Ben to share a video about what the data collection actually looked like.
Awesome. And just to reiterate what Rachel said, I see some good questions from Jackie and Lois in the chat. Those are great questions that we'd like to hit in the Q&A session. So make sure to pop those into the Q&A feed. You'll see along the Zoom tools tab, you'll see a little Q&A tab where you can post those questions so that we make sure we don't miss them. And I will go ahead and start that video for the data collection tutorial.
Sounds great. All right, so this was a tutorial we released to everyone collecting data to walk them through what it actually looked like. And so you come to a screen here where you're asked to look at a tutorial before you begin to walk you through the process, and then we invite you to start. And you see the cam loaded right there in the main screen. And the buttons are here on the right-hand side, just like you saw in the screenshot. And you're able to click the buttons as the behavior happens in real time. You can see that every click shows up down below, and you can delete anything you click accidentally so that the session is what you think is the best estimate of what happened. And if there are any questions during the data collection, we made a field guide so that you can check with what you knew, what was happening with the hawks. And at the end, you would click that button, and you collected data. It was just as easy as that, where you could enjoy watching the cam and help gather some information while you did it. All right. And so we had a lot of fun collecting data this past summer. We did so for about 3 weeks. And after 3 weeks, we had over 12,500 observations from 323 people, which we were thrilled with. That's a lot of data to work with. And we took the time, about a month or so, to turn that data into visualization so that we could all explore it together and try to use our knowledge about what we knew about the hawks and what we watched while we were collecting data to figure out the patterns that we could see in the visualizations and see how it answered our questions. And with that, I'm going to share some data with you all. I just want to point out I won't have time to go into all of the data, but that's okay. We've made a page for you to explore by yourself. So Ben's going to put the page in the chat, and I'm going to share my screen again. This time, one of the visualizations, one of the ones we thought was really interesting, and we've had some conversations online already with people about what they think is going on. All right. All right. So is my screen up and visible? Okay. So what you're seeing is a graph that is looking at one aspect of our research question and thinking about it in terms of feeding. And I want to give the opportunity, instead of me just telling you what I think this graph is telling us, if anyone wants to go into the chat and offer their interpretation as to what you think is going on with this graph. Because like I said, we want this to be a two-way street, and we want your interpretations to be just as important. And for those of you who haven't seen this graph before or are trying to discern what's going on, the temperature is increasing on the horizontal axis from 30 to 39 degrees Fahrenheit up to, it looks like for the morning it reaches 70 to 79, and you're seeing on the vertical axis the total number of feedings that happened at the nest. And that includes self-feeding and the adults feeding the nestlings. And it looks like Shelby's pointing it out, the warmer the morning, the more the feedings. Yeah. And the temperature could coincide with some other things that are going on. That's a good observation. Yep, you guys are hitting it on the head. Looks like as temperature increases, the number of feedings is increasing. I'm going to go ahead and click on some more data.
And remember, for those of you, some of you might be very accomplished data scientists in your own right. And right now, often the first step of looking at data, for those of you who maybe are less, fluent in data, a big chunk of it is actually exploring the data. And one of the challenges is, how do we take complex data and make it available to be explored by everyone on a website somewhere without someone necessarily to hold your hand or to answer questions. And so one of the things that we've done is definitely pared down the things that we're looking at into fairly simple visualizations. And what you can do is you can look at multiple visualizations of different kinds of factors and then come up with hypotheses about what those things are telling you that could lead to more sort of complicated statistical analysis. So what we're not showing you right now are the statistical analyses saying definitely A plus B equals C, but we're saying, okay, here's one graph that shows like A and B seem to add up to C, okay? And so there's other ways we would go about, you know, looking at the statistical importance of that relationship. But I just want to stress, you know, because I've seen some of the comments roll in, you know, think of this more as like exploring a couple of factors at a time and seeing, and then together we can put together all of these and you can share what you think is going on. And I think, Rachel, there's also something about this data, right? They can look at it themselves as well,
Yes.
right?
Yeah, so what's really neat about the visualizations, what we tried to put together so that we could both explore it, the scientists and the community as a whole, were these two buttons here. So you can click this data button and click it and make the graphs yourself and look at the actual hard numbers in a table format, so that you can, on your own terms, see what's going on. But yeah, I think everyone is interpreting this graph really well. They're thinking about that temperature increases, what else is going on potentially, and the fact that it's reflecting what we were talking about earlier. And I'll click on, and something else neat about the visualizations, you can put more or less data into a graph. And so if we look at morning, midday, and evening, we see the same pattern. So we can account for time, but we can't account for, like what many people were saying, maybe we should take into account and look at age of the nestlings. Maybe we should look at some other things that might be going on. But like Charles was saying, you can only fit so much into a graph, and this is the first step. So that kind of helps us think about the next things we need to do in an actual kind of analysis step.
Right, and this is an important thing. Some people aren't visual, you know, so we understand that maybe these visualizations don't necessarily help everybody with exploring the data. Sometimes tabular data, people can read those numbers. But these are the sorts of things that, again, it's kind of like asking the question. You ask a question, you intuit your, what you think is going to happen. Is it going to increase, decrease, stay the same? And then you start picking apart all the things you have to learn in order to tell whether or not any increase or decrease is due to the things you think it is. And so the same thing with these visualizations, you see temperature, you see number of feedings, okay? All right, well, one thing that everybody's pointing out is like, gosh, the time of year might really matter. You know, maybe bigger chicks need more food. Maybe so that would be in a multivariate, sort of a multiple variable analysis, another variable that we could pop in there. We could also make a graph that maybe just has age, irrespective of temperature, and shows number of feedings and see, oh, does it increase? Because if it doesn't increase over time, then maybe it's less to do about age, more about temperature, okay? But again, it's hard to do that in a way unless you already understand statistics and are, feel comfortable with them, where you get to actually start exploring that, okay? So again, just like put it in that box and then hopefully it makes a little bit more sense too.
Right. And it looks like people are offering great ideas for what could be going on about hydration and thinking about variation. But Ben, I want to open it up to any questions that have been posted in the Q&A right now in the interest of time, because we could probably keep talking about this for hours, but unfortunately we don't have that time today. So I'd like to address some of the points you guys are bringing up.
Yeah, so we've got a couple questions submitted so far, looking into or asking questions about the sampling effort during data collection. Edwin asks, number one, oh, sorry, that's a different question. Jackie asked, how long was the average data collection session? And then following up with that, Lois asked, was our data collection spread sufficiently over the data collection period? Or could there have been data skewed by the volunteer or participants' availability during that period?
Right, and that's something that Ed Butler brought up in the chat, which I think is why you started saying, Ed, could these variations be related to the amount of observations, for example, more data in midday? So they're all hitting on the same question there, and you are the data expert. You know what the back end of this data looked like. So what can you tell us about the data sampling?
So I want to just say, I'm so glad you all asked that and are thinking about that, because that's something that is so important to every single scientific investigation, is thinking about the sampling and how you do it. And is it representative of what's actually going on in the world? And so in response to people in past investigations wanting to understand and get a handle on that, we actually made those graphs. And so I'm going to go ahead and put a link in the chat for you all if you want to click and explore how the sampling effort varied. It did vary. We did have some days where people were watching for longer, and we did have some days where people watching for shorter. In terms of the average session length, it was about 9 minutes or so, but the variation was huge. We had some people that would log on and log off really quickly. And then we had some people that would watch for an hour or more. And so definitely the variation was large, but it was really neat to see how that varied, because if we do a official analysis, that's something we can account for, which is really cool. And that's something that's come up in the citizen science field, is that the data is really useful. Even if our sampling effort varies, we can put that in the model to see if it's driving the patterns or not.
Yeah, and I think this whole idea of sampling really hits upon something that when you have a controlled experiment, you can do a really good job of trying to account for sampling, meaning to have samples in enough time periods that you think are important to capture the diversity to answer the question that you're asking, right? But the cool thing about these cameras and having a bunch of people watching is, yes, there's probably some bias to the data, but the scale at which we're watching is also much different than what a typical scientific study would uncover. So if you go and look in the literature for what do red-tailed hawks bring in to the nest, what you find are a few old musty studies, primarily from, literally decades to half centuries ago, where a handful of samples, a handful of like observations during an entire breeding season, or going up to the nest at the end of the breeding season and looking at some of the bones, or in some cases, I think this was back in the 40s, tethering a nest on the ground so you could watch. I mean, like, it's really not an easy thing to do unless you have a camera right there and happen to be watching. And so one of the neat things about these cameras is they do sort of unlock the complete picture of what is happening in a nest. But that's just for one nest. So then the problem is, how do you contextualize what's happening in that one nest to talk about what happens in red-tailed hawks? Because you don't know if you just have an incredibly awesome set of hawks and most of the other red-tailed hawks are just not as cool. They're just maybe just not as successful or whatever. So that's why science often relies on many more samples across individuals, okay, to sort of paint a picture that gets very close to probably what generally is sort of truth for that question. Whereas for the red-tailed hawks on Cornell, we're able to paint a very detailed picture of what their life is like. And then we can go to the literature and say their life falls within kind of what the literature says their lives are, or maybe it's not, but sort of it doesn't redefine what a red-tailed hawk is, but it gives us a very rich portrait of what a red-tailed hawk life is. And that's sort of one of the main values of these kind of cameras for scientific data.
Yeah, that's a great point, Charles. And I think you kind of hit on Linda's question, which was, number one, why are we collecting this data? And is data collection just for this pair of hawks? Or can you extrapolate it beyond this pair to what red-tailed hawks do in general? So I don't know if there's any other point you want to make about the importance of scale in terms of scientific study, or we can move on to Jackie's follow-up question, whereas people look at these behaviors that we're interested in looking at. We've come up, the community's devised in this investigation. But Jackie's wondering, where can I find good studies to read? And she often finds it difficult to locate the information that she wants. And that can certainly be helpful when you're, trying to refine a question for scientific investigation.
Great question.
That's actually a great question.
Yeah.
Yeah, go ahead, Rachel. Sorry, go ahead.
I was gonna say the scientific community in and of themselves have realized that's a problem even for scientists who are professionally trained. When they're not linked up to a university, it's hard to sometimes find those studies that have been done. And so, let alone it's hard for the whole world to find out what's been done. I would first definitely emphasize your libraries near you. Some libraries have really good databases, and there a lot of red-tailed hawk studies that I've come across have been like talked about and published in some books on red-tailed hawks. So if you're specifically interested in that, you can look that up. I also want to point to a resource that the lab has really been working on this past year. Birds of the World is a really awesome online resource where you can search for any species that you want, and it kind of coalesces a lot of research in one central place. And Ben's sharing his screen right now. And while there is a small subscription fee to access that, if you're not already a member, it's where I go to always when I'm trying to find the answer to a question about a bird.
Yeah, and it might be that your local library has access to this,
Yes.
or if you live near a university, like if you live near Cornell, which not all of you do, but I know some of you do, or to another university, a lot of times the university libraries will have access to this. And if it's a, an agricultural university like Cornell, often those resources are open to citizens outside the university community. The other thing about these is they'll have a bunch of different sections where you can read sort of essentially what is a summarization of what is known across all the research that was able to be found. But you can also go down to, the references, and, most of these are, scientific papers. They're not sort of written for a lay audience, but if you really want to dig into the details of how do we know X, Y, or Z, you dig into the references, and every once in a while you're like, gosh, I don't really think we know it that well, and I mean, like that formed the foundation for some of my master's research. When I read a paper and it made me mad that it even got published. It's like, how did that get published? That doesn't mean that, so a big challenge too is actually understanding what the question is that you're trying to, the kind of information that you're trying to get. So identification type information, general overviews of life history. You can find that stuff online pretty well. You can look for it in a book, like something like, if you wanted to learn more about hawks, you could look at something like, how to identify them from far away, or books that maybe have a little bit more of a natural history bent to them. But at the end of the day, they're actually, for red-tailed hawks, there's a surprisingly small amount of things written, despite how common they are. So, the other thing you can do is read all that stuff for yourself and decide, I want to become an expert, and maybe you can write the next sort of awesome red-tailed hawk oriented resource for sort of a community of people like the people that follow cameras. Yeah, even eBird can answer a lot of questions. That's what I was getting at. That whole top panel on that Birds of the World page basically comes directly from eBird. Those same images, same range maps, all that kind of same thing.
That's a great answer. Yeah, there's a lot of resources out there that can help you dive deeper into red-tailed hawks and what we know and what we don't know about them so far. Do we have time for another question? Okay.
I'd say we have time for one more.
Awesome. Valerie asks, which do you think was better in terms of participation in data collection, the live data collection or data collection from archived video clips? Do we have any sense of that? She may be referring to a previous investigation that we did with BirdCam's lab called Hawk Talk, where we were diving into different vocalizations and their associations with different behaviors in the nest. Mm-hmm. And we sort of did that data collection and investigation a little bit differently on a online citizen science platform called Zooniverse, where you can collect more refined data from video clips, where you can rewatch and collect data rather than collecting data live as it's happening on cam. So if either of you want to touch on which maybe you think is a better source of data collection or how they differ.
Yeah, so great question. We thought a lot about that on our end as well, thinking about how data collection works for people in an archived way and in a live way. And honestly, the two tools, the archived and the live data collection, allow you to get at different levels of a question. And so the live data collection, we were able to collect something about like frequency about a behavior, but we weren't able to ask them some deeper questions about like the type of vocalization. Like we couldn't dig down as deep as we might want to. And so that's the awesomeness of having both tools. You kind of can have the first stab and then the second stab. In terms of participation from people, we had pretty great participation from the community in both environments. We had, I think, different groups of people. So the CAM environment was something that people who watch the CAMs are used to doing. And so it was catered more to that community. The Zooniverse community, there were a lot of people who had no idea who CAMs or BirdCam's lab were, and they joined us because they were really passionate about data collection in that space. And so they're two tools that are both really useful for different types of questions. And we saw participation from many people from slightly different communities.
That's great. Yeah. I want to fit in one more question if we can really quick.
Sure.
This is from Sister Mary Veronica Sabelli in the Q&A. And she's asking, I have discovered other red-tailed hawk cams other places online, such as the Syracuse University cam and other cams. Would it be possible to do a study like this across many nests in different locations?
Yeah, I mean, it's a great question, and it actually gets towards the scale that is starting to become more possible now. And it's something that we've talked about as kind of a little bit of a holy grail since, soon after this project started. And that is, what can we learn about birds by utilizing both the power of online audiences and what is beginning to be multiple cameras for individual species scattered across a broader area. So yes, it's certainly getting to the point where it's technically possible. And for it to become really powerful, ideally the more cameras the better, the broader the audience the better, and the more similar the questions are. So a big challenge is getting everybody focused on the same questions, motivated to answer them. And that's on both the participants, side, the people like yourselves out there answering along with us, but also on the people running the camera side. So there's two sides to that. And so in the case of live stuff, it doesn't create necessarily a giant lift for somebody running a camera, but for archived, like in Zooniverse, where we're using saved clips, that does become, so in the case of Marietta, Syracuse, and the Presidio out in San Francisco, those are all different red-tailed hawk cameras. But when I contacted them, none of them had saved recordings, like whole season recordings, for example. So the idea that we could take sort of a census of ours, a census of theirs, and look at how, what sort of a variable picture it forms, instead of like this beautiful, rich portrait of one family, that's, very nice. How similar would the other portraits be? Where would we find overlap? Where would they be quite different? And then you start asking the questions, why? So I did reach out to Anne-Marie, and you did say that you had many recordings. At the time, I was just looking for really long, sort of season-long recordings. So it's still something I think that's possible, depending on the scale of the recordings and the question. And it comes down a lot to that question. And also looking forward, if it's a goal to have recordings for that, for answering that question, then making sure those recordings get made, or potentially doing it in a live environment, which has its pros and cons as well. So great question. And I appreciate you chiming in, Anne-Marie, because you were one of the people I reached out to.
All right. Well, it's been a lot of fun, everyone. I wish we could keep talking. Unfortunately, we are at time, a little bit over time, actually. And I don't want to keep you, but I do want to point you to resources, and thank you again for watching. Please keep exploring with us. We aren't done exploring the data, and we want to hear from you in terms of interpreting it. So we have a link here, and Ben's going to post a link in the chat. Please also follow us on Twitter. We are updating our BirdCam's lab account to keep everyone up to date with the most recent happenings across all our investigations. And then also, please feel free to contact us if you have any questions. And we're also looking and trying to build up getting the raw data sets to all of you. So if you have any interest in looking at that raw data, please email us and let us know. We would love to know your interest and why you might want to look at that data so we can build that part of this whole process out together. All right. So thank you. Have a wonderful rest of your day and hope to see you again in BirdCam's lab.
Thanks, everybody. It's been great listening into your chatting, and thanks for asking such great questions and also like engaging with what we were talking about. I love it when people are going, hey, wait a minute, what about this? You know, that means you're actually listening, and that was kind of the point too. So thanks for keeping us on our toes, and looking forward to the next one.
Yep. Thanks a lot, folks.
All right, bye-bye.